Good afternoon, everyone, and thank you for introducing us. I'm Daniela Pasini, and this is Claudio Milati. We are working in the same research team supervised by Professor Pavane and Professor Lagnotti at the Politecnico di Milano, Department of Architecture, Environment and Construction Engineering. The presentation of today will focus on IFC-based processes that are adopted within the construction sector, in particular for proposing an automated method for improving the information flow based on the IFC format. In particular, after a brief analysis of the background, we will define our problem statement and we will present the methodology that has been adopted during the research for proposing and testing for different scenarios for the exchange of information. After that, we will conclude with some final remarks. As all of us know, IFC is the international standard for interoperability. It's a standard recognized thanks to the ISO 16739. However, there are currently a lot of problems and a lot of barriers in the effective adoption of this format within the construction industry, especially with regard to the Italian construction sector. This is for many reasons, and among those reasons, the main are related to the redundancy of the IFC schema. As an example, IFC represents objects, their attributes and properties, but also the relationships among those objects and the properties. But because of this high redundancy of the schema, different assumptions and interpretation can be provided when expressing the same information. As an example, if we consider a window, we can represent it as an opening within a wall related to a space. But at the same time, we can relate the window to the space through the building story. So it's a cause of different problems and different interpretation in expressing the same information. Moreover, we have also to consider the ambiguous quality of IFC certification processes of BIM authoring tools as IFC exporter and importer. There are several problems also in this direction, and the barriers can be overcome by the different users when they can, personalize both the import and export option of IFC formats within BIM authoring tools. Anyway, the customization and the personalization of these options requires often advanced IT skills from building operators. Because of all of this reason, when the exchange of information is based on IFC format, there's the possibility of information loss. It is for this reason that during our research we try to establish and to propose a method based on the connection of information stored within IFC formats with external databases and through automated processes. Why we decided to adopt this solution? Because, as an example, among the main benefits that can be derived, there's the limited size of BIM models, as information are not stored, not all the information is stored within the model, but it is stored also in an external database that is bidirectionally linked to the IFC form. Moreover, there's also the possibility to store information that are not considered in the IFC schema, or there's the possibility and the opportunity to add a specific property set to the IFC. The process can also be repeated as it is not specific for one single project, and the skills that are required to be building operators are reduced because of the automated process. Therefore, after reviewing the state-of-the-art approaches mainly used and mainly adopted in the construction sector, we analyze the main obstacle in actual processes for proposing different workflows. And from the evaluation of pros and cons of those solutions, we develop the automated process. Particularly, the 4 workflows that have been analyzed concern the first one, the translation of native formats into IFC files through basic processes. That is the process mainly used and mainly adopted within the Italian construction sector. In this case, there's a lot of information can be missed, can be lost. Therefore, a manual integration could allow them to customize the export options of IFC format within beam authoring tools allow to improve and can be considered a step further in the research. The third scenario that is considered concerns the creation of an IFC format as a native model, and the fourth one is the automated process of the translation in order to prevent the loss of information. For adopting these different workflows, several tools have been adopted, and in particular, those tools are used for translating the IFC, and in this case, we are referring to beam authoring tools. Tools are also used for reading IFC, and in this case, we refer to model viewers, and tools are used for writing on IFC, and in this case, it's mainly Python encoded tools. So, starting from the first workflow, we translate a native beam models, native formats into an IFC format, and in this case we have to consider the fact that several users generally devote a lot of effort in modeling a great amount of information within a beam model. Anyway, if the users use the standard export setting of commercially available solution software, lots of this information can be lost. In particular, we tested this workflow using Autodesk Revit as beam authoring tool, and then we verified the IFC file with the solid model viewer. In particular, if we try to model specific properties of materials that are used and associated to objects in the beam models. And when we export the IFC file using the standard export settings, a great amount of this information is missed. The same result can be reached when we add to the objects some specific properties. So for overcoming this barrier, we try to customize the IFC export option. In particular, in this case, the solution is difficult to be adopted within the construction sector for two reasons. Because it is required a deep knowledge of both the IFC schema, but the IFC structure and the export schema of a specific software. In this case, we use Autodesk Revit also because an online community provides an open source code that can be modified in Visual Basic, so using a C# language. And in this case, so we customize the export option, and the model that we obtained, that we verified within the solid model viewer is a complete model. In this case, the disadvantages is related to the difficulties of the application in the construction sector, because the users generally don't have enough skills and enough competencies in enough knowledge of the IFC structure and of the export schema.
Perfect. So following our test, we now imagine to start from an IFC model, correct IFC model, an original IFC model that can be ideally generated directly right in the IFC, or maybe obtained using the reduce process. And then we test the reading, and reading the model using a model viewer, we can see that no information lost, so we don't have information lost in the reading process. But now the question is, what's happened when I want to insert new information in the IFC model, and I don't want to return in the original format? So we try to push the information directly in the IFC model in order to understand if after the introduction of this information, these information are maintained also in the reading part. So we try to develop a simple script that can read information provided by an external source and can write directly this information in the IFC model. And the script was developed using Python. And then using Solid Model Viewer, we confirm that all the information that we inserted inside of the IFC model are maintained in the reading process. So the final model has both the information provided from the IFC model in its original format and all the information that we decide to push inside of the IFC model, defining an enriched model equal. Then, summing the different processes that we saw before, we try to define a global process that can help the construction sector in using the IFC format, avoiding the data loss. The first part of the process is the same that we represent, and that can be used by the construction industry, because use the standard setting of the beam anchoring tool. So the user have only to use the standard setting and obtaining an FC that may have information loss. Then we defined an automated process that can detect this information lost and that can write directly this information inside of the IFC model. And as we have seen in the previous process, all the information that we push inside of the IFC model are maintained, and so in the final model we have all the information that were in the original one. This process has been developed using the standard setting of Revit and using the Python script that we saw before, based on the information that are stored in a Postgres database. How the Postgres database is populated. So the process that can detect the information lost is this one. So the process that we developed read all the information that are contained in the original model in its native format and write all the information inside of that temporary database, a standard relational database. Then another part of the script can access the IFC model and report all the information of the IFC model inside of the same database. And then with a query, you can understand which information are lost and obtaining a final database where all the information that are not presented in the IFC but are in the original model are listed. So this part is the part that can populate the Postgres database, and that can be used to push all the information with the other script in the IFC model. Then this is a simple representation of an extraction of the script that can read the information on the IFC format and a part of the database where the information are reported. And here there are two tables, one about the instance element and one about the type element. And in conclusion, with this process, what we can achieve, the users can directly export the IFC, the native format in the IFC format, and using our process can overcome the data loss, because the automated process can detect information that are not reported in the IFC and can write directly this information inside of the IFC. On the other hand, if, for example, you obtain at the end of the process an empty list, you are sure that all the information that are in the native model are in the IFC1, so you have a sort of verification of the quality of the IFC at the end. The limitation of this study is that we test only the tests that we have developed are only on non-geometrical information. So future development of this part of this work will be on trying to understand if there are some geometrical information that can be validated, and so if there are geometrical information that are lost during the process, if we can avoid also this part and complete the entire process. So thank you.